Hello students. So in the previous class you saw what is the average velocity and when is velocity 0. So what is the or what condition the velocity will be 0. So if the velocity has to be 0, then displacement has to be 0. If displacement is 0, then velocity is 0. So if time is 0, then velocity will not be 0. If time is 0, then velocity, like as per the mathematical equation, it will be infinity. So which is not possible. So we cannot calculate when the time is 0. So only if displacement is 0, then velocity will be 0. So with this, we'll move to the next concept, that is acceleration. So you must have seen in your bike or car, so they say accelerate. So what happens if we accelerate more? The speed will be more. So if you are going slowly, maybe at 20 km/h, if the odometer that is there on your bike, but is reading 20, so what happens when you accelerate more? So when you accelerate, then the speed will increase. So it will go to a different value. So let's say 40 km/h. So it is picking up, or the speed is increasing. The velocity is increasing. So acceleration is nothing but change of velocity by time. So this, if you want to define, it is nothing but rate of change of velocity. You can, because since there is divided by time, you can read it as rate of change of velocity. It is nothing but acceleration. So when you say change of velocity, so there is a change in velocity. So from when to when, or from what point, or from what value to what value. So in the last class you have seen uv. So u is nothing but initial velocity, whereas v is final velocity. So with this you can write it as change in velocity or change of velocity. It means that final velocity minus initial velocity, that is v final velocity minus u initial velocity time t. So this acceleration is represented as a. So a is equal to v minus u by t, that is final velocity minus initial velocity divided by time. So if you want to know the unit of acceleration, this is important. So one thing what I say is, don't try to memorize all the units. So if you know the formula, from this formula you can get the units of acceleration or velocity, whatever. So you know that it is velocity. So what is the unit of velocity? It is meter by second or meter per second. Unit of time is second. So what happens here? Meter will be on top, seconds will come down, that is it will become second square. So the unit of acceleration is meter per second square, or you can also write this meter per second square. So this is the unit of acceleration. So you need to know this. You don't have to remember, you need to know this. This is very important. So with this, I will solve one of the problems. So what they say is, starting from a stationary position. So starting from a stationary position. So I want to erase this. I'll use the same equation. So starting from a stationary position, Rahul pedals his bicycle to attain a velocity of 6 meters per second in 30 seconds. Then he applies brake such that the velocity of the bicycle comes down to 4 meters per second in next 5 seconds. So calculate the acceleration of the bicycle in both the cases. So there are two different cases. So first, let's take first. The first case, he is starting from the stationary position. So there is no velocity. Velocity is 0. So in the first case, initial velocity, since he is not started, the velocity will be 0 meter per second. Next, what they have given is, he attains or pedals his bicycle to attain a velocity of 6 meter per second. So finally he attains a velocity of 6 meter per second. The time that he takes is 30 seconds. So in this 30 seconds, starting from 0, he goes to 6 meter per second in 30 seconds. So they are asking what is the acceleration. So that is v minus u by t. V is 6, u is 0, time is 30. So it is 6 by 30, 1 by 5. That is nothing but 0.2 meter per second square. So the acceleration is 0.2 meter per second square. So in the next situation, there is one more situation. Then he applies a brake. So what happens when I apply a brake, or when you are going on a bicycle and suddenly you apply a brake? So the speed decreases, right? So here also, then he applies a brake such that the velocity of the bicycle comes down to 4 meter per second in the next 5 seconds. So here he is traveling at a velocity of 6 meter per second. So here initial velocity will be 6 meter per second. When he applies a brake, the velocity decreases and it comes down to 4 meter per second. So the final velocity is 4 meter per second, because that is how I am traveling with 6 meter per second now. So that will be my initial velocity. In second case, when I apply the brake, the velocity decreases. So it becomes 4 meter per second. So the time that he takes is 5 seconds. So what is the acceleration? Initial velocity, final velocity 4 minus initial velocity 6 by 5, that is 2 by 5. So sorry, it is minus 2, minus 0.4 meters per second square. So here you need to mention minus, since the acceleration is decreasing. So it is also called as decelerating. So since the acceleration is decreasing, so obviously it will become minus. So don't get panicked since you are getting minus. So this is also correct, because since the velocity is decreasing, the acceleration will be in negative. So next, we have graphical representation. So in the previous classes, I discussed about uniform motion, non-uniform motion. So this here will represent this in graph and say, is it traveling in uniform motion or non-uniform motion? For this class, I'll just take 2 examples. So with this, in the next class, I'll explain how do you get the equations and how to solve it. So suppose say, so let me take whatever they have given in the textbook. So initially they have taken distance, time, graph. Okay. Time. This is y-axis, x-axis. In x-axis you are taking time, whereas in y-axis you are taking distance. Suppose, so let's tabulate the values. Time in 0, distance will also be 0. So in 1 second, if it travels 10 meter, in 2 seconds 20 meter, 3 seconds 30 meter, 4 seconds 40 meter and so on. So in time 0, distance is also 0. So 1, 2, 3, 4, 5. Here 10, 20, 30, 40, 50. So in 0 it is 0. In 1 second it is 10. In 2 seconds it is 20. In 3, 30. 4, 40. So when I draw a line, it will become a straight line. So if any object is traveling in uniform motion, so this is how the graph will be. So let's take a non-uniform motion and explain. So same, it is time, x-axis. This is distance, y-axis. 1, 2, 4. So in 0, if it is 0, in 1 second if it travels 10 meter, next 2 seconds if it is traveling say, if it is increasing, say 100 meter, then in 3 seconds if it becomes 1000 meter, so it is rising exponentially. Or in 0 it is 0, in 1 second it is 10 meter, then in 2 seconds it goes to somewhere. So if I take the straight line 50, 60, 70, 80, 90, 100, so in 2 seconds it becomes 100. So whereas in 3 seconds it goes somewhere here, so it's increasing like this. So this is not a straight line. So if you take some other values, it will be like this. So this is also called as exponentially, like it is exponentially increasing. It is not linearly. So this is linear because this is a straight line, whereas this, it's not straight line. So this is increasing exponentially. So if any object is traveling in uniform motion, so the graph will be straight line. If any object is traveling in non-uniform motion, the graph might be anything. Here, since it is traveling exponentially, the graph will be like this. If it is traveling with variations, like maybe for 2 seconds instead of 10, if it is 25, next 30, so it can be like 10, next 25, 30. So it can be, the graph can be like any shape. So there is no perfect shape for non-uniform motion. So in next classes we will be solving some more time graphs as well as acceleration graphs. So with that we will try to see how to solve the problems. So as a great philosopher or spiritual leader Swami Vivekananda says, education is the manifestation of perfection already in man. So don't waste your time. So use it wisely and effectively. Till then, till the next class, thank you. Have a great day.